learners, welcome to your favorite e-learning platform Pathshala. I'm Savita Chauhan, your mathematics mentor. Let's just start a new chapter today called as construction. So in the previous classes, we have also done the construction using the geometrical tools like the ruler or the compass, and we have drawn the perpendicular bisector of the line segment, and we also have done the constructions which are related with the triangle. So now we are actually talking about some of the other steps, or we can say some of the other types of constructions which are all related with the division of a line segment, and also which is related with the construction of some other kind of triangle along with their justification. So let's just move on further with the very first concept of this particular chapter, which is nothing but called as the division of a line segment. So as per the definition, or as per we can say the heading, it says the division of a line segment. What does it mean? It means that let us suppose we have a line segment, let us suppose we have any particular line segment, and we just have to divide that line segment in a particular ratio, and we have to show this into the formation of a construction or with the help of a construction. So how we can do such type of a construction in which we can divide a particular line segment in a particular ratio which will be given to us. Let's just see how we can do it. So let us suppose we are starting with the very first construction, that is the construction number 1, which says to divide a line segment in a given ratio. So let us suppose we have to divide a line segment in a particular ratio, and we are supposing that ratio is to be what? So let us suppose if I am starting the construction as given a line segment AB, let us suppose we have any particular line segment AB of any measure. We want to divide it into the ratio m:n. So we have to divide that particular line segment in any ratio m:n. So at first we have taken the ray, but instead of taking a ray, we have to, or instead of taking a line, we have to take a line segment, because we are totally concentrating on a line segment rather than on a line. So in the first part, or in the starting, we have taken a line, but instead of line, we are basically talking about line segment. So mind this, because our topic is all about division of a line segment. So here we are working only with a line segment. So it says given a line segment AB, we want to divide it into the ratio m:n, where both m and n are positive integers. So they both are positive integers, and let us suppose we are considering m and n as nothing but m is nothing but 3 and n is nothing but 2. So let us suppose we are supposing that we have to divide a particular line segment AB of any measure in a ratio 3:2, then how we can do it? So let's just see this step by step. So first of all, I'm starting with the steps of construction of this particular construction. So let's just see the first of all steps of construction. So the very first step of construction would be like draw any ray AX making an acute angle with AB. What does it mean? First of all, we have to draw the line segment using the help of a ruler. So let us suppose if I'm drawing a line segment over here, which is nothing but AB of any particular measure which would be given to us in the question. So first of all, using the help of the ruler, I have drawn a line segment AB of any measure over here, and the very first step of construction says that draw any ray AX. Draw any ray AX means we have to draw any ray AX making an acute angle with AB. So with AB, the ray AX would make an acute angle. So let us suppose if I am drawing with the help of this scale this particular ray, which would be called as AX, and this AX ray is making an acute angle with this AB. So this is my very first step of construction. So always remember, whenever we have to divide a particular line segment in any particular ratio, so first of all we have to draw a line segment AB using the help of the scale, and then afterwards we have to draw a ray AX using the help of the scale, which will make an acute angle, which is less than 90, an acute angle with this particular line segment AB. Now this is my step number 1. Now let's just move on further with the step number to using this particular construction. Now let us suppose if I'm taking this step and I'm moving ahead toward the step number 2. So the step number 2 was like we have to locate 5, that is m plus n points, a1, a2, a3, a4, a5 on ax, so that all these segments or all these sections are equal to each other. What does it mean? It means that the very first step was like we have to draw the line segment AB, and then we have to draw the ray AX, which will make an angle of or which will make an acute angle with this particular line segment. So the next step would be like using the help of the compass, taking A as a center, we have to draw, that is 5 points on this particular ray. Why 5 points? We always have to take the sum of the ratio that would be given to us. We know that the ratio given to us is nothing but 3:2. So take the sum of the ratio, that is 3 plus 2, which is nothing but is equal to 5. So the step is like we have to take the number of points as m plus n. So let us suppose if the ratio given to us is nothing but 7:4, then we have to take their sum, that is 7 plus 4, which is equal to 11, and we have to take 11 points on this particular ray AX, and those points would be equal in particular units. So let us suppose if I'm starting with this question, so we know that we have to locate 5 points on this particular ray. So let us suppose if I'm starting with the help of the compass, taking A as a center and any particular radius. You can take any particular radius, and we have to mark an arc. Over here on this particular ray AX. So let us suppose I'm marking the very first arc over here, taking A as a center, using the compass, we have to mark an arc over here, and let us suppose this is my very first arc, and I'm calling this as nothing but A1. This is my A1, and again using the same radius, taking A1 as a center, mark an arc again, and such that arc would be definitely called as nothing but A2. Again using the same concept, taking A2 as the center, mark an arc again, and this will be our A3 point. Now again taking A3 as a center, mark an arc and call it as nothing but A4, and let's just move on further toward A5, taking A4 as a center. So taking A4 as a center again, using the compass, I'm marking an arc again of the same radius that we have taken at the point A. So this arc is nothing but called as A5, and always remember that this distance A1 or this distance A1 A2, A2 A3, A3 A4, A4 A5, they are always equal to each other. So this is the step number 2, that we have to locate these points on this particular ray AX such that their distances, that is A1, A1 A2, A2 A3, A3 A4, A4 A5, they are always equal to each other. So this is our step number 2. Now let's just move on further to our step number 3. So the step number 3 will say that we have to join BA5. So join B and our last A5 arc, that is this one. So we have to join BA5. So let's just join BA5. This is our next step, that is the 3rd step in which we have to join BA5. So we are done with it. Now let's just move on further towards the step number 4. So the step number 4 says that through the point A3, that is m is equal to 3, draw a line parallel to A5B. Now this is really an important concept because this will help us to find out the point exactly at which this line segment is divided in the ratio 3:2. Now the next step would be like through the point A3, as we have seen, this is our point A3. Through the point A3, why we are taking A3 only? Because we know that the ratio we want to take is nothing but 3:2, or the ratio in which we want to divide this line segment is nothing but 3:2. So 3 comes first, so we are taking 3 units first. Let us suppose if the ratio was 5:2, so we have to take 5 units first and then 2. So it means we have to take A3, this is our A3, and again taking A3, we have to draw a line in such a way that it should be parallel to BA5. So draw. The next step would be like we have to draw a line which is from A3 in such a way that it should be parallel to A5B and their angles should be equal to each other. So how we can do this? We can measure the angle over here. We can measure the angle which is made by this BA5 with this AX. So let us suppose, using the help of the compass, if I am measuring this particular angle. So let us suppose if I am measuring this particular angle using A5 as a center, I am measuring this particular angle. So let us suppose if I have marked this particular angle over here, and again taking this point as a center, we can measure this arc. We can measure this arc using the compass. So again I am making this same angle on A5. I'm making this angle same on A5. So first of all, I am marking an arc over here, taking A3 as a center, and again using this using compass again I am measuring this arc in just this manner. So I am taking this particular point as a center and I'm taking this distance, and using that distance I am marking an arc over here. I'm marking an arc over here in such a manner. So I have marked an arc over here, and let us suppose if I'll draw a line, in such a manner, and that line would be parallel to this BA5. So wherever this line would intersect this particular line segment AB, that point would be nothing but called as the C point. That point would be called as nothing but the C point, and this will divide the line segment AB into the ratio 3:2. This will divide the line segment AB into the ratio 3:2. Moreover, you can see this also with the help of the justification that why we are calling this as 3:2. Because let us suppose if I am saying or I'm talking about its justification, that why we are saying that this is nothing but 3:2, because we know that, first of all, we know that this line is actually parallel to this one. If this line is parallel to this one and this is forming a triangle, then by the basic proportionality theorem, so by basic proportionality theorem, we will say that AA3 by A3A5 should be is equal to AC by CB. We can say this because if this line is nothing but parallel to this one and this is nothing but a triangle, then by the BPT theorem we can say that the ratio of this and this should be is equal to the ratio of AC by CB. And if they are equal to each other, then by construction we know that AA3 by A3A5 is nothing but 3/2. Why so? Because by construction we know that all these smaller sections are always equal to each other. So these are 3 units in total. 1, 2, 3. These are 3 units in total, and these are 2 units in total. That is 1 and 2. So this is nothing but 3/2. So using the equation number 1 and using the equation number 2, we can say that from 1 and 2 we can say that AC by CB is nothing but is equal to 3/2, because if this is equal to 3/2, it means this is also equal to 3/2, and it means AC by CB is equal to 3/2, and hence this is nothing but the justification of this particular construction, that AC or this particular line CA3, wherever it will intersect the AB, this will divide the whole line segment into the ratio 3:2. So this is all about the construction which is related with the division of a line segment. So it involves a really important step which is all about drawing this particular line parallel to this BA5. So let us suppose if I'll recall all the steps. First of all, we have to draw the line segment AB, then we have to draw any particular ray AX which will make an acute angle with the BA or AB line segment, and then we have to locate m plus n number of points on this particular ray AX using the help of the compass, taking any particular radius such that their units should be equal to each other, or we can say AA1 should be equal to A1, A2 should be equal to A2, A3, and so goes on. And at the end we have to join B with the last arc, and we have to measure the angle which it is making with the AX ray and and with the same angle we have to draw the line at the point A3. At the point A3 we have to draw a line of the same measure using the help of the compass. So let us suppose, if I'll recall all the steps over here, first of all we have to draw an arc over here. We have to draw an arc over here using A5 as a center, and again at the point A3 we have to draw the same arc over here. Then we have to measure this arc in such a manner using the help of the compass, and then we have to draw an arc over here as well in the same manner, and wherever this particular arc will intersect this one, we have to draw a line which will come exactly parallel to this line, that is BA5, or wherever it cuts the line segment, that would definitely be into the ratio 3:2. So this is all about our construction number 1. I hope all the steps related to this is all clear to you along with its justification.